So what we're going to do to start out today is I'm going to go through my review of the frequently made mistakes from assignment 1B. First, please make sure you document your code thoroughly. It's not enough just to put your code underneath my specification comments. You need to actually comment the code itself. Also, please don't remove the to-do, you fill in here tags. I use those so I can zip around really quickly and figure out where to look at your code. So if you remove that, then I have to go through manually and it's very complicated. So let's start by taking a look at some of the issues with the spin lock implementations. The first one here is a strange implementation in getOwner, where the person is calling a concurrent set. I'm not sure what that's doing, but it's not a good thing. It's actually changing the contents of the, or potentially changing the contents of the lock value. That's not supposed to happen. You're just supposed to return the lock value. Let's take a look at some problems with try-lock. This code is not thread safe. The reason it's not thread safe is that set and get are two operations, and there's a window of time where you can sneak in there and cause problems, where multiple threads will cause problems to check to see whether something is not set, and then it'll set it. So that's, of course, defeating the whole purpose of atomic operations. So don't do that. You need to use the concurrent set operation. This code here is way more complicated than it needs to be. There is no real need to check for exceptions. There's no need to have these flags, et cetera, et cetera. Just call concurrent set and you're done. So very simple. Now let's start getting into some problems with lock. A lot of people had subtle problems with lock. So the first thing is make sure you use try lock in your lock implementation. And number two, make sure you first check to see whether the owner is null. So that's a little optimization. By checking to see if the owner is null before you call try lock, that'll be better for the cache. What that's basically saying is if nobody's using this lock, then try to do the concurrent set. If somebody's got the lock held, there's no sense in calling concurrent set, and it causes cache problems. So make sure you do that. Also make sure that you check in here whether is canceled equals true, because that's why we have that is canceled supplier as the parameter to lock, so that in that case you can detect whether or not you've been informed to shut down. It's a clever way of being able to keep the lock from spinning indefinitely when someone wants to shut the thread down. And then also make sure you add a thread yield here at the end of the loop, just before you loop back around again. And the reason for that is that if you're spinning and there's other threads that are waiting, you want to give them a chance to do their thing first. So let's take a look at another problem. Here we have a local variable called gotLock. We don't need that, so rewrite your code to not require a Boolean like this. Not sure why there's a call to value.get here, because it's not really doing anything, but you don't need it. You don't also need this outer loop. You don't need to check to see while gotLock. You can hoist things up, so you first check to see whether owner is null, and then if it is null, then you call try lock. So that's, again, a way to optimize this. I'm not sure why there's a call to value.get here. It's not being used for anything. Down here, you don't need to check to see whether you can refactor this code, and that'll make it better. And let's see, that part's fine. So we'll just do this. Let's now take a look at unlock. There's a lot of problems in unlock as well. The whole point of the atomic operations is to do something atomically and then see what the result is and use that result to guide whatever it is you're going to have to take as the next step. So the problem here is there will be no exception if get and set is called. Get and set doesn't throw an exception, so there's no reason to catch the exception. So this is going to check, you need to check the return value from get and set as opposed to expecting an exception to be thrown, which it'll never happen. So that code won't work. Here's another problem. This is another good example of having issues with, well, there's a bunch of different problems here. First of all, this code is not atomic. And secondly, you don't want to use concurrent set. Concurrent set doesn't do what you think it does. It will potentially not give the return value. It will not set the value if it's not already true. So this is just busted code that doesn't work. Another problem, this code here doesn't actually meet the specification comment above because it doesn't check to see if the lock is not held by the current owner and does not throw the illegal monitor state exception. So all kinds of problems there as well. And then down here, similar set of problems. This code is not atomic. because you're checking something and then you're calling get and set. So you need to make sure that you combine calling get and set and checking the return value, and then throwing the exception if the return value is not to your liking. And then down here, yet more problems. This is just way too complicated. I'm not even really sure what's going on here, but it's way more complicated than it needs to be. I think this is the grad student implementation, but it's not checking the current owner correctly. It's not supposed to check whether the current owner is null. It's supposed to check whether it's equal to the current thread. And it's just way too complicated. So this code could be simplified. This is the grad student version, though. It's the recursive spin lock. Okay, so a lot of things to be fixed in the spin lock or recursive spin lock implementations. Please, or reentrant spin lock, I think I called it. Please make sure you're running the unit test. The unit test should catch a lot of these problems. They may not catch every one of them, but they'll catch a lot of them. So if you're getting errors when you run the unit test, that's a good sign that there's something amiss in your code. So please make sure that you fix that stuff accordingly. All right, now let's transition into issues related to the spin lock, the HashMap manager, the spin lock HashMap manager, I think it's called. And we'll start off with some syntax issues. So you should get in the habit of using the most basic interface or most basic superclass. So that would be cancelable lock, not reentrant spin lock. The message that you get with that bug from the unit test is a little cryptic, but that's basically what it's trying to tell you. A lot of people were having problems with creating the right type of semaphore. So the build model is basically what we call a virtual constructor. It's where the initialization gets done. And you need to make sure that you make a fair semaphore, not an unfair semaphore. So you have to pass the right parameter there. So this one just uses the default, which is to use non-fair semantics. This one's actually passing false, which is also making a non-fair semaphore, which you don't want to do. And down here, this is not only giving the wrong type of semaphore, but it's also giving the wrong permits count. So those are all things you need to make sure you fix. It's not too hard to do this right, but make sure you do it right. Now let's start taking a look at acquire. Lots and lots and lots and lots and lots of problems with acquire. So this particular code does not acquire the semaphore, nor does it lock the spin lock. So the code will have serious problems with respect to race conditions. You also don't need to call is canceled here. That's not something you need to do there. You handle that by passing the right method reference to the lock method on the spin lock, which should of course be called. Here's some other issues. A bunch of people, to their credit, were trying to do clever things with Java streams. Good job for doing that. If you know what you're doing, you can do it. I mean, if you know the subtleties, but this particular approach is less efficient than it should be because it's calling replace down here. And we don't want to have to call replace. What we want to do instead is we want to go and find an available map entry and set its value to true, meaning that it's in use. And so you'll basically, you set its value to false. Sorry. If it's available, it's true, and you set it to false. So this code is along the right lines, but it's not quite there. So you can either figure out how to do that type of thing with streams, which is doable, and some people did. And again, great job for that. But it might be easier just to use a for each loop using the entry set factory method on the Palantiri map, and then using the get value and get key and set value and so on methods on a map entry. That's probably a simpler way to do it. But if you want to do it with streams, that's fine. It just make sure you do it right. This code, forgot to acquire the semaphore before doing anything else, so that's going to cause problems. Make sure you pass the right value to the lock method. You need to pass it a parameter that's going to be the is cancelable method reference. This code here will always be false, which means that the get will always return false, which means it can never be interrupted, which is not what you want at all. You don't need to have this Boolean. You don't need to have this outer while loop. You should not be using get Palantiri. Instead, use m Palantiri entry set. So you'll get basically a for each loop with the map entry each time. And don't use contains key. Don't check to see if p is null. Don't use put and get. Those require hashing. This code is very, very inefficient relative to what you can do if you use what I suggest here, using map entry and the corresponding get and set methods. Way better way to go, and be faster and actually shorter too. Yet some more problems, passing the wrong parameter to lock again. Don't do that. Pass the method reference to the isCanceled method. Don't use key set either. Use entry set. Key set returns the keys in the map. We want entry set, which includes the key value bindings. And again, don't use get and replace here. And make sure you don't call unlock in the middle of the loop. You want to make sure you call unlock at the end of the loop, or after the loop. After the loop is done, you want to put the whole thing in a try finally block, and make sure you call unlock in the finally block that surrounds the loop. And make sure you don't call release on the semaphore. That kind of totally defeats the purpose of having a semaphore. If your acquire method then releases a semaphore, that means that there are going to be more beings able to gaze than there are semaphore palantiria, or there'll be more beings trying to gaze than there are palantiria available. And crazy things will happen in that case. Let's now transition to release. Release is surprisingly subtle. One thing you don't need to call contains key. You don't need to call get or anything like that. Once again, passing the wrong value to lock as the parameter. Pass the isCancelable method reference, please. Don't just call put. You can also call release. Don't call put or sorry, not release, replace. Don't call put or replace without storing the value that comes back from it and then using that in some way or another. So you'll only release the semaphore if what comes back from put or replace is boolean.false, all caps for false. Don't call get here. There's no reason to do this. Just store that as a flag and check the flag to decide if you want to release something. And make sure that you use the right try finally block syntax and semantics in order to release the cancelable lock, no matter what happens. Calling get is not the right thing to do here. So you just want to make sure you put that on a finally block. Keeping on here, this code here is acquiring the lock before checking to see if Palantir is null. That is not the end of the world, by the way. It's not a bug. It's just faster to check if Palantir is null. And if it is, you're just going to throw that exception. You are out of there. There's no need to acquire the lock because there's no race condition on Palantir since it's a parameter to the release method. This code, again, you need to make sure you take the return value from put or replace and check it. And then down here, again, don't call get here. Instead, what you want to do is you want to keep track of the results of the return value from put or replace and use that as a flag to decide if you want to release something. So that's unnecessary here at this call. Or it's better to do it a more concise way. This call to replace needs to be, this call to replace needs to be inside the try block. And this code here is, I don't think it's wrong. It's just way more complicated than it needs to be. So you can kind of merge together some of those conditions a bit. And you can also, for example, refactor this code so that you don't have to call unlock in two places. You can refactor the code so you only call unlock in one place, and then you can conditionally decide whether or not you want to release the semaphore. So the code's not wrong per se, it just could be made a little bit more concise, so that's a good habit to get into. Wow, this code has lots of issues. So there's no need to call key set contains, there's no need to call map get, all that stuff should go away. You should, and this is the biggest problem. You have to lock the lock before you do anything relating to the state of the spin lock, or the hash set spin lock manager, or whatever the class is called. You have to make sure that you lock that lock before you start poking around with the map, because the map is not synchronized. It's an unsynchronized collection, which is what you get out of the box with HashMap. And so therefore you have to lock stuff before you try to check it. Again, make sure you call put when get the return value or replace and stash it away. Also, always make sure that you call unlock in a finally block. Don't call it by itself, because when exceptions are thrown, the unlock will be skipped. And make sure you only release things properly if the return value from put or replace was what you expected. Basically, should be false. And I'm not quite sure what this is doing here, but it's also inefficient. And it's not thread safe because, of course, we're accessing the contents of the Palantir map without being inside a critical section. So chaos and insanity may ensue.